So I'm going to review now, actually, example number 17, which is one of the examples that were assigned for in the breakout rooms last time. So we gave the answer, but we didn't really review the example. Here's what the example looked like. It's on exercise practice example sheet 2. By the way, a few people said that they were having trouble reading some of the parts of the sheet because I hadn't sent it as a PDF. So I resent the exact sheet only in PDF form. So if any of the things were missing, you should be able to see them now. Here's what the example looks like. It says, determine the equation of the line described and put the answer in standard form. We want the line to go through the point -4, -3, and be perpendicular to the line -9x plus 5y equals 8. Okay, I'm going to just put the line down here so we have two sections. Remember that when we want to write the equation of a line, we want to write the y equals mx plus b, the slope-intercept form of the equation. It actually asks us in this question to put the answer in standard form. We're going to talk about how do we go from one format to the other. But this equation happens to be in standard format. We're going to write an equation in the slope-intercept format, in the y equals mx plus b form, that's going to be perpendicular to this line. And excuse me. Hello? Yeah. Hi. Yeah, I know. I happen to be in the middle of teaching a class. Can I call you back? I'll call you back. Okay, bye. Okay, so we're starting out with an equation of a line, which happens to be in standard format because it has the x's and the y's equal a number. We're going to want to write an equation of a line that's perpendicular to this line and passing through this point. And what we said is whenever we want to write the equation of a line, the first thing we're going to be looking for is what is its slope? How do we find the slope of the line? And the hint over here to find the slope of the line is that it's going to be perpendicular to this line. And we know that perpendicular lines have opposite reciprocal slopes. In other words, if I can find out, let's call this line 1, the slope of line 1, I will then be able to flip that fraction over and switch its sign, and that will give me the slope of the line that I'm looking to find the equation of, the slope of line 2. In order to find the slope of the line, when we have the equation, what we do is we put it in the y equals mx plus b form. So first I'm going to add 9x to both sides. So this is going to give me 5y equals 9x plus 8. And then I'm going to divide by 5. So the original line that they gave me in y equals mx plus b form is y equals 9 over 5 times x plus 8 over 5. interested in is what is the slope of the line. The slope of this line then must be the coefficient of the x, which is 9/5. So the perpendicular line slope would have to be this number flipped over, which is 5/9, and switch signs. This is positive, so this is going to be negative. This is the slope of the line that's perpendicular to the original line. The slopes are opposite or negative reciprocals. So I have my first thing in writing the equation of this line. I know what its slope is. It's -5/9. The next thing I want to do is figure out what the b is. So in order to find out what the b is, I take the point that they gave me. They told me one of the points on the line. They only told me 1 point, but all I need is 1 point. I know for 1 point, when the x is -4, the y is -3. So I'm going to replace the y by -3, and I'm going to replace the x with -4. And that'll give me -3 equals -5/9 times -4 plus b. I'll put these things over 1 because when we have fractions and whole numbers, it's best to keep everything as fractions so we can tell what's in the numerator and what's in the denominator. Okay, so this simplified gives me -3/1 equals, now we're going to multiply, there's nothing canceling out, so we're just getting -5 times -4, which is +20/9 plus b/1. And remember what we do, we multiply everything by the common denominator, which is 1 times 9 times 9. Everything here will divide into 9. 9/1 is my common denominator. I'm distributing the 9/1, so it's 9/1 times -3/1 equals 9/1 times 20/9 plus 9/1 times b/1. This gives me 9 times -3/1, which is -27/1, or just plain -27. Here, the 9 on top cancels out with the 9 on the bottom, and I just have 1 times 20/1, which is 20. And this, nothing cancels out, so it becomes 9b/1, which is just 9b. And this, then, I can solve for b by bringing the 20 to the other side. Which will give me -47, this cancels out, equal 9b. And my b turns out to be -47/9. So I'm going to erase this part because we don't need it anymore. I now have all the information that I need for line number 2, the line that I wanted to write the equation of. My line is y equals my -5/9, because my slope is -5/9, so it's -5/9x. And my b is -47/9. In the slope-intercept form, this is the equation of the line that I'm looking for. That really would normally be what I would ask you to find. I usually tell you to find the line in slope-intercept form. They actually asked me to put it in standard form. When we want to put an equation in standard form, we don't want to have any fractions, number one. And we want to have all the x's and y's on one side. Now this is really a y over 1. That's the only thing that's not a fraction. And if I look at my denominators, there's 1, 9, and 9. Obviously, my common denominator again, the denominator that all of these numbers will divide into is 9. So I'm going to put 9 over 1 and multiply everything by 9 over 1. So it's y over 1 equals negative 5 over 9 times x minus 47 over 9. I distribute the 9 like I did before, so it's 9y over 1, which is just 9y, equals 9 over 1 times negative 5 over 9x minus 9 over 1 times 47 over 9. Notice in both of these 9's cancel out, so I'm left with just 9y equaling negative 5x, because the 9's canceled out. I'm just left with a negative 5 here. And here again, the 9's canceled out, and that's minus 47. And I'll bring the 5x to the other side. So that my equation in standard form is 5x plus 9y equals negative 47. So that is a lot of work. These are probably one of the hardest types of examples that you might encounter in this whole term. This is complex, but this would be the work you'd have to do in order to get the line in standard form. Again, I would be perfectly happy if you left the answer in slope-intercept form. Does anybody have any questions to ask me? If not, what I'm going to do is I'm going to give you one to try on your own. Okay? Here's an example of the type of thing you might have to do. This is actually example number 12 on our exercise sheet 2. Determine the equation of the line described and put the answer in slope-intercept form, which is the format that we usually get. They want us to write the equation of the line whose y-intercept is equal to negative 5, and which is parallel to the line y equals negative 3x plus 7. Okay, I'm going to give you a few minutes to work this out on your own. Okay, I think you should have had enough time to work this out. Let's see if we can together come up with the correct answer. We want to write an equation of a line in the slope-intercept form, y equals mx plus b. And we want that line, let's work on the slope first. We want that line to be parallel to the line y equals negative 3x plus 7. Well, we know when we have parallel lines, the slopes are exactly the same. The slopes are equal. What is the slope of this line? The slope of this line, notice it says y equals, so the slope is a number in front of the x, is negative 3. I know that the slope of my original line is negative 3, which tells me that the slope of my, let's call this line 1, the slope of my line that I want to write for this example also has to be negative 3. In other words, y will equal negative 3x plus b. The two lines have to have the same slope because they are parallel. When they're perpendicular, they have opposite reciprocal slopes. When they're parallel, they have the exact same slope. Okay, if that's the case, what we need to do is now find what the b is. But they even actually told me what the b is. They told me that the y-intercept is negative 5. That means, remember, the b is the y-intercept. That means the b has to be equal to negative 5. So my equation then is y equals negative 3x minus 5. This actually had it's a similar idea in terms of we're writing the equation of a line, but it actually was much easier because the numbers were easier to work with and less work involved. But this is the type of thing you should be able to do. Any questions about how to write the equation of a line? Anybody want to ask me any questions or put it on the chat? Okay. I'm going to just finish up the last topic that's going to be included on the test that you're going to be having next week. I will discuss with you what the test is going to, how it's going to be presented. And then I'm going to introduce our SI, Shireen Hodge. Shireen, who's going to be helping us doing examples. If you looked on your Blackboard, you should have seen her schedule, and she'll give us her login information for you. We'll let her talk for a couple of minutes, and then we'll go on to some new work after that. But the first thing I want to do is finish up the last topic that is included in this week's work. It's the last few problems on practice sheet 2. Let's just take this equation for a second. Y equals negative 3x minus 5. It happens to be the equation of the line that we just were discussing. If you noticed, there are two variables in this equation, and I can't really solve the equation. I can't find what is x, but if I can give you a value for x, then you could figure out what the value for y is. Let's say if x equals 2, then your y will equal negative 3 times 2 minus 5, which is negative 6 minus 5, or negative 11. In other words, 2, negative 11 is an ordered pair that fits into the equation, or another way of saying that, 2, negative 11 is a point on the line. notice what we've done. I arbitrarily picked a value for x and then figured out what the y would be depending on what the value of x I picked. Note that we call x what we call the independent variable. I just picked any number I wanted to. But once I picked a value for x, then my y was set. That's why y is called the dependent variable. The value of y depends on whatever value you picked for x. Suppose I picked x to be -5. Then your y would equal -3 times -5 minus 5, which would be -15 minus 5, or -20. And we write the order pair as -5, -20. Again, I can figure out what the y is if you first decide what your x could be. I'm picking my x arbitrarily, but then I have to find what the y is. Okay. If one of the things you might have noticed is that once I gave you a value for x, how many values of y did you find? Exactly 1. For each x that I gave you, for each x that I picked, and it could have been 2 million for x, it could have been -100 for x, any number that I picked for x, as soon as I picked my value for x, I was able to find exactly 1 value for y. When we have that kind of situation, it doesn't always work. It doesn't always work that if you gave a value of x, you only get 1 answer for y. But if it happens that I'm going to write this down, for each x that you pick, you get exactly 1 y. Very important, you only get 1 y every time. Notice different x's give you different y's, but anytime I picked the x, there was only 1 answer. That type of situation is called a function. Actually, those are the type of situations we prefer using in mathematics. It's so exact. 1 x, 1 y. 1 question, 1 answer. Sometimes you get more than 1 answer. It doesn't always work, but if it does work, that's great. We really like it. And because we like it so much, we give it a special name. We call it a function. And not only do we give it a special name, we also give it a special notation. Sometimes instead of writing y, we write something that looks like this, f parentheses x. It's read f of x. And you don't only have to use a letter f. It could be g. You could write g of x. You could write h of x. A lot of different letters. Usually we use the letters F, G, and H, those type of letters, but F of X or G of X or H of X, they're just different names for Y. What's the advantage? I only use this type of notation if what I have is a function. If I'm calling something g of x, I know it's a function, which means that every time I pick an x, I'll have exactly 1 answer for y. I don't even have to think about it. I don't have to prove it. I don't have to anything. Just the use of that functional notation tells me that what we're dealing with is a function, which means each x has exactly 1 y. So let's take this example here. This was a case where every time I picked an x, I got exactly one y. So this is a function. So instead of calling it y, I'm going to write it f of x. I'm going to write f of x equals negative 3x minus 5. So all I'm doing is giving, it's like somebody having two different names. They might have their formal name, which is Harris, and then they might have their nickname, which is Harry. Sometimes they're called Harris, and sometimes they're called Harry. But the same person, the same thing is with f of x. Sometimes we call him y, and sometimes we call him f of x. They're two names for the exact same object. What's the advantage of using this f of x? It tells me automatically that what I'm dealing with is a function. It's a situation where 1x gives me, in other words, one question gives me one y, one answer. Each question has its own individual answer. There's another thing we can do with this functional notation. You could write, say, find, for example, f of 1. What I want you to do when I say find f of 1 is go to your f of x, look what's on the other side of the equal sign, and replace, this is f of x, and you're replacing the x over here by 1. So on the other side, again, replace the x by 1. In other words, this will then become negative 3. Well, now your x is 1 because I'm doing f of 1 minus 5. And I can work this out, and this gives me negative 3 times 1, negative 3 minus 5, which gives me negative 8. So f of 1 is equal to negative 8. What is that telling you? That's telling you when I pick the x to be 1, the y, the one y value that works when x is 1 is negative 8. Or if we look at this as an equation of a line, the point 1 comma negative 8 is a point on this line. It's a ordered pair that makes the equation true. So we can either say 1 comma negative 8, or we can say f of 1 is equal to negative 8. Let's try another one. Giving you something a little more complicated. Suppose I tell you that f of x is equal to x squared minus 2x plus 1. That's one function. I know it's a function because I'm using f of x. And here's my second function. I'm not going to call it f of x. I'm now going to call it g of x to distinguish it because it's a different function. Let's say it's equal to 2x plus 3. These are two functions. I know there's functions because I'm using functional notation. In each case, as soon as I pick a value for x, I'm going to get one answer for y. Okay, here's my first, I'm going to give you a couple of questions. Question number A, I'm going to ask you to figure them out. Find f of negative 2. Question B, find g of negative 2. And question C, find f of 0. I'm going to give you a couple of minutes to try that on your own. Okay, I think we're going to try these together now and see how this works out. First of all, we want to figure out what f of negative 2 is. Since this is f of negative 2, I know I have to go to equation number 1 because that's the f equation. And wherever I see an x, I'm going to replace it with negative 2. Now, since numbers work a little bit differently than letters, what we're going to do is wherever I have an x, I'm going to put a parentheses. So the first thing is going to be negative 2 squared. Remember, I put that in parentheses. Minus 2. Now, I can't just put negative 2 next to it. I have to put it in parentheses, negative 2 plus 1. Remember that when you're doing something like this, you first have to do exponents, then multiplication and division, and then addition and subtraction. That's what we call the order of operations. So the first thing I see is there an exponent. The negative 2 is squared. That means to do negative 2 times negative 2, which is positive 4. Then I have negative 2 times negative 2. That's a multiplication. That gives me a positive 4, and that's plus 1. So this is 4 plus 4 plus 1, which gives you 9. F of 2, negative 2, is 9. Notice this is not a linear equation. This is not, if I would try to graph it, I would not get a straight
For number
line.
A, isn't it supposed to be negative 4? I got negative 4 for the first one. For negative 2 to the second power?
No, because negative 2 to the second power means negative 2 times negative 2. You're squaring the negative 2. You're not just squaring the 2, you're squaring the
Yeah, thank you. Never mind.
Okay. Let's just, even though this is not a linear equation, if I were to graph it, and we will do graphing of these type of things later on in the term, it's still something that if I would have graphed it, one of the points on that graph would have been the point negative 2, 9. When the x is negative 2, the y turns out to be 9. Again, I can either say negative 2, 9 in parentheses, or I can say f of negative 2 equals 9. Again, remember what f of negative 2 means. It means if I pick the x value to be negative 2, what is the y value going to be? Now the B asks me what is g of negative 2. Notice by using different letters for f and g, it's very easy to tell which equation I want you to look at. I now want you to look at the g equation. G of x is 2x plus 3. So g of negative 2 is 2 times, remember I'm replacing the x with negative 2 plus 3. So this will give me negative 4 plus 3, which is equal to negative 1. G of negative 2 is negative 1. In this equation, when I pick the x to be negative 2, the y turns out to be negative 1. And finally, f of 0 means replace your x with 0. So this is going to be 0 squared minus 2 times 0 plus 1. And 0 squared is going to be with 0, and negative 2 times 0 is going to be 0, so this is just going to equal to 1. In other words, when x is 0, this y is going to be equal to 1. And if you remember, when the x is 0, that's where it crosses the y-axis. If I ask you what is the y-intercept of this, even though it's not a straight line, it still has a place where it's crossing the y-axis. It happens to be when when the y is 1, the y-intercept is 1. In other words, y-intercepts you can always find by putting the x equal to 0. But this is how functional notation works. Just to go a step further with this, suppose I gave you this equation, f of x. And suppose I asked you to find f of w. Usually, I give you a regular number over here for the x. But now I'm not giving you a regular number, I'm just giving you a letter. Well, f of w means wherever you see an x, replace it with w. So that's easy enough. This will become y equals 2w squared minus 5w minus 3. So you don't only have to, you can use functional notation even when these are not regular numbers, but they're other variables. Okay, I'm going to go a step further. What if I asked you to find f of 2a? What would that mean? That would mean wherever you have an x in your original equation, replace that x with 2a. That'll mean this is going to be 2. Here's your x. The x is your 2a. That's going to be squared. Minus 5. Now in place of your x, here's your parentheses. You're putting in a 2a. Minus 3. Now you have to be careful with the algebra. Remember, order of operations. First exponents, then multiplication, then addition. So this is 2a squared, which means it's 2a times 2a. That's what 2a squared means. Which means it's 4a squared. So this means that we're doing 2 times 4a squared minus 5 times 2a, well, 5, that's negative 10a, minus 3, and I'm almost finished. 2 times 4a squared is 8a squared, minus 10a, minus 3. I can't get any further on this because these are not like terms. Notice I actually can do this even with variables. Just be careful with your algebra, making sure you do the exponents, the order of operations correctly. Okay, I'm going to give you a couple to try while I take attendance. I'm going to be taking attendance now, but I'm going to write some problems on the board. Okay, so I want you in the first example to figure out what g of 3x is. if this is g of x, and in the second exam, I mean, if this is f of x, and in the second exam, I want you to find what g of x plus 2 is if g of x is 4x plus 1. I'm going to give you time while I'm taking attendance, and then we'll go over those together. Abdul Ali. Abdul, you're here? Ashley. Ashley Compton. Ashley, are you here? Yesenia.
Here.
Okay, great. Dominique.
Yeah.
Okay, good. Darlenis. Darlenis.
Here.
So, Angelina. Angelina Alexander. Angelina. Wendy.
Here.
Jesha. Jesha. Kalucia. Kalucia Chang. Kalucia.
Here.
Okay, good. Devante. Devante. Devante Covington. Victor. Victor, you here?
Yeah, I'm here.
Kizzy Ellis. Kizzy.
I'm here.
Kizzy, have you gone on to the Delta?
Yeah, you asked me the other day. I told you I did the assignments already.
Okay,
Yeah,
sorry.
it's okay.
I'm a little dizzy with all the people that are in the class. So
Yeah, I know. It's okay.
thanks. Shania. Shania Frank.
Here.
Okay, good. Anaya. Anaya. Anaya Glover. Bernardo. Bernardo Gomez. Tara Goodwin. Tara.
Here.
Oh, good. Thank you. Mariellis Hernandez. Mariellis. Mariellis. Kalinda Ginty. Kalinda. Kalinda Ginty. Fatu. Fatu Karamoko. Fatu, you here? Fatu. Samaya Knight. Samaya.
I'm here.
Okay, good. Monique Lawrence. Monique? Letty Luna. Letty here. Brenda Mendoza. Brenda?
Hi, I'm here.
Okay, good. Brianna Minzy. Brianna Minzy. Judy Molina.
Here.
Okay, good. Naira Netter.
Here.
Okay, good. Samantha Ortiz. Samantha? Samantha here? Amilta Perez. Amilta? Odalis Perez.
I'm here.
Okay, good. Octavia Pratt. Octavia? Octavia here? Raja Wajahat. Raja?
Here.
Okay, good. Were you here last time?
Yeah.
Oh, because I marked you absent. Kathy Ramos. Kathy, I think I saw you on the,
Hey, I'm here.
yeah, you're on the chat also. John Edward Salazar. John Edward? John Edward here? Okay. Jessica Asada. Jessica?
Here.
Okay. Karina Guzman. Karina? Alexandra Salvatierra.
Here.
Okay, good. Genesis Stevens. Genesis here? Jaasia Swabi. Jaasia.
Here.
Okay, good. Maya Watkins.
Here.
Okay, good. Angelina. Angelina Behari Lau. Ashanti Forbes. Ashanti?
Asanta or Ashanti?
Okay, good, Ashanti. And
Asanta
Asanta,
Hawthorne.
oh, you're, okay. There's
Yeah.
Asanta and there's an Ashanti. Is
Yeah,
it-
I'm Asanta Hawthorne.
Okay, I have you. Great. Were you
Okay.
here last time?
Yeah, I was.
Okay. Sometimes, if you don't answer quick enough or I took attendance after you got on.
Oh,
Okay. All right. And Ashanti Forbes, I take it, is not here. Okay. All right. Is there anybody whose name was not called? All right. So let's look at these problems. I see somebody came up with an answer. Abdul, I did call your name. Let me see if I marked you absent. I marked you absent. Okay, I took you off my absent list, Abdul. let's get the answer to this, and we'll talk about SI, and we'll talk about the test, and then we'll finish up what we're gonna do today. Okay, let's look at first f of 3x. Now, what does it mean? If this is what f of x is, then what it means is to take wherever I see an x and replace it with 3x. So this is going to be 2. Here's my x. It's now 3x because I'm doing f of 3x. I'm squaring that. Minus 5. Again, this is going to be times 3x now, not just times x, because I'm replacing these x with 3x minus 3. Now, that means I have to first do 3x squared. 3x squared means 3x times 3x, which gives me 9x squared. So this is 2 times 9x squared minus 15x minus 3. I'm going to put this down a little bit lower. So here I have to do 2 times 9x squared, which is 18x squared, minus 15x, and minus 3. And I can't get any further than this because these are not like terms. My final answer is 18x squared plus minus 15x minus 3. Okay, no problem, Kizzy. Let's go on to this. How do I find if g of x is equal to 4x plus 1, what does it mean to find g of x plus 2? That means where I have an x in my original thing, I'm going to replace that with x plus 2. So this is going to be 4. Here's my x. My x is no longer x, it's an x plus 2 plus 1. And I have to simplify this. I use the distributive property. This is 4x plus 8 plus the 1. So my final answer is 4x plus 9. So we can use it's not x plus 9, but it's 4x plus 9. Don't forget the x had to be multiplied by the 4 as well. So therefore, we can use this functional notation even in more complex situations where we don't actually know this number, but it is all it is, whatever is over here. I literally take out the x on this side, erase it, and replace it with this, whatever this is. We usually have to put in a parentheses there because of the way algebra is written. Is there any question about this now? Okay, so now let's just stop for a minute and talk about the test that's going to be given on Tuesday. And then I'm going to introduce our SI person. Okay, first of all, I announced that there's going to be a test on Tuesday. I decided this first test is going to be given on Delta Math. It will be posted after class on Tuesday, sometime around 2 o'clock, let's say 2:30. And I'll send you out an email to tell you that it is posted. And I will give you 24 hours from that time to complete the test on Delta Math. Now, it's going to be different than our regular exercises because each question you're only going to be able to, you're going to have one chance to get the right answer. If you get the right answer, then you go on to the next problem. You can do more problems of the same kind, but you won't get additional points. If you get your answer wrong, you can either go on to the next problem because you don't know how to do it and that's it, or you can try another problem. You won't get full credit if you did 2 attempts. The first question you got wrong, but you did the second one right, you won't get full credit. Let's say there's going to be 10 questions, so each question is going to be worth 10 points. You won't get the full 10 points, but you will get partial credit. So, and it will be calculated by Delta Math. So our first test is going to be on Delta Math, again, after class on Tuesday. The next test after that, I will probably give you on Blackboard. So to get you used to taking tests on Blackboard as well. We have for this class an SI person. Her name is Shireen. Shireen, are you available to talk?
Yes, I'm available to talk. Sorry for the webcam. I'm having issues.
Okay. Can you tell us do you know what your login information is going to be?
Yes, I sent it to you earlier.
Oh, okay. So I will email everybody the login information. I didn't look after I started class, so I didn't see it.
It's okay.
And do you want to just talk a few minutes about what you do and how you do and what SI is all about? I'll give you a couple minutes.
Sure. So good afternoon, guys. My name is Shreen Hudson, and as Professor Weinberg said, I'm the SI leader from your class, as well as her other section class.
And we're so lucky. I have to tell you, we are very lucky.
So what we do is basically we're assigned to your class and we help facilitate what the professors are teaching. And we have our own sessions, and as Professor Weinberg said, she posted them, but don't worry, I'll be sending weekly emails. And there are some days where they have conversion days, so I'll let you know those types of days as well. What we do facilitate, if you have any questions about what the teacher went over, you're free to come to my sessions and ask me those questions, and I'll help you the best way I can. I also do review for tests, especially for the midterm and final. Let's see what else. Well, yeah, that's basically it. As I don't worry, starting from Monday, once I get all of your emails, I will send you the link again, because there's a specific way when you guys sign in for my sessions, because we're trying to keep attendance, because I know some of you probably are for like ASAP and you guys have to have certain tutor hours. So if we keep track of your attendance for our sessions, we'll send them to ASAP. So the way we want you guys to set up your username for once you guys get the link, because we start next week on the 14th, and my sessions are Tuesday to Friday. You have to put your full name, first and last name, and your employee ID, so we'll know who is who. But don't worry, I'll send weekly reminders.
Okay. Shireen, do you want me to send you their email addresses, or can you log on to my Blackboard account?
I'm not familiar with logging it on, so if you could send me the emails and the roster for both class, that would be good.
Okay, I'll do that. I have to tell you that, let me just tell the class that Shireen has been my SI. I think this is at least the 4th term. Am I correct?
Yes, this would be, or the 3rd term.
The 3rd term? It's just the 3rd.
Yeah, the 3rd.
In any case, my experience has been that the students who made use of her services have done much better on the finals and the midterms than those students that haven't. So is it mandatory? No, unless I'll tell you that it's mandatory. Sometimes I will say it's mandatory because I'll see somebody's marks are so low that I need you to go. I do not make SI mandatory, but if you do use the SI, Shireen will let me know, and I will use it to, if it might, to increase your score. Like say it'll add a couple of points to your exam marks, so you will have a higher average. I do consider going to SI sessions as points when I'm counting up your final grade. Does that answer your question? Somebody had, okay, so yes, it is optional, but yes, you will get, it's gonna be on Zoom.
No, it's Blackboard Collaborate.
It's on that Blackboard Collaborate, but there will be a link.
Yeah, there will be a link.
I'll let you know what the link is. Okay? Is there any other question?
And just to add on, if I know some of you, because you guys have classes certain times, if you can't make it for my class, I'll send a schedule for all my other peers who have their SI sessions. There's SI sessions for different subjects like English and bio and chem. So if you guys have any of those classes, I'll send, once we set up everything, I'll send you guys my colleagues' schedules.
And if you have, I see somebody asked, they have been assigned other tutors. If you can get them to email me that you are attending their sessions, then I will give you credit for that as well. Is that okay? So if you, but I strongly, as I said, I strongly recommend Shireen, because she's been working with me. She knows how I do things, and therefore she will go over the way I do it. Sometimes it gets confusing if you have a different tutor who's looking at things differently. Sometimes it gives you another way of doing things, but sometimes it just confuses. So see which one you like better, and you can work it out. But if you have been assigned a different tutor and you want the credit, I would, as long as I get some information from your tutor as to that you're attending those sessions. Okay? That being said, I'm going to go back to what we were talking. Let me just reiterate what we've covered through functional notation. That will be on the test that is being given on Tuesday. Basically, what the test is going to be covering is what I've assigned you on already on Delta Math. It's solving equations, inequalities, absolute value equations, graphing of lines, finding slope, and writing equations of lines, and using functional notation. There are a total of 10 questions that you have to do. Don't forget to make sure to do it in the time prescribed. Again, you'll be given a total of 24 hours. So at some point, it shouldn't take you more than a half an hour to do the examples. 10 questions should be able to be done in a half an hour, but I'm not giving you a time limit. It just has to be done during that time span. Okay, I want to now start with the next section. This is actually starting chapter 3 in the text, and it's called something called systems of equations. What we're going to have is, instead of having just one equation, we're going to have two equations. We're going to have something that might look like this. One equation might be the equation x plus y equals 5. And the other equation, let's call this equation number 1. And my other equation, here's another example of another equation, y equals 2x minus 1. Two different equations. Of course, I could call this f of x. I could call, if I put this y equals, I could call it g of x. They're two different equations. It's called a system of equations. We have two variables, so we have two equations. There are systems of equations with even more variables and more equations. If there are three variables, you need 3 equations. If there's 4 variables, you need 4 equations. We don't go into such complex systems of equations. We're going to deal with systems of equations where we're going to have 2 variables, usually x and y, and 2 equations. And what do we want to do with the system of equations? What we want to do is solve the system of equations. If you think about it, the system of equations, each of these equations, they're each linear equations, they each represent a line. Let's say it's something like this. One line might be like this. This is not a graph of the situation, but we might have one line that goes like this, and we might have another line that goes like this. What's happening with these 2 lines? Well, in the most common situation when you have 2 lines on a graph is the 2 lines intersect. And when the 2 lines intersect, what does it mean? They're meeting at a point. There is a point where these 2 lines meet. That point, the point that's on both lines, is what's called the solution of the system of equations. And it's obvious when you have 2 straight lines, they can't meet at more than one point. So there is exactly one solution to the system of equations. Notice, since it's a point, it's going to have 2 numbers, one number being the x and one number being the y. But the system of equation is going to have a single solution. This is what's called a consistent system of equations, where the 2 lines intersect and the point where they meet is the solution. It's a consistent system of equations. Before I actually go to solve this, let me talk about what other situations could arise. There are actually 2 other things that could happen. One, when you go to your system of equations, you graph your first line. Let's say that's line number 1. And then you graph your second line. It's line number 2. And it turns out that the 2 lines are parallel. That's something that could happen. Well, if the 2 lines are parallel, they're never going to meet, which means there is no solution. If the solution is the point where they meet and they never meet, then there's no solution. Sometimes written like this. And this is what's called an inconsistent system of equations. Actually, as you're working it out, pretty early in the working out of the problem, you would notice that your lines are parallel, because you could see that they have the same slope. If two lines have the same slope, they are parallel, and therefore those two lines would be an inconsistent system of equations and there would be no solution. So that doesn't happen very frequently, but that's something to look out for. There actually is a third scenario that might happen. You go to draw your lines, and here's your first line, line number 1. And then you go to draw your second line. And when you do the second line, it turns out that line number 2 falls right on top of line number 1. In other words, maybe when you started out with them, they didn't look like they are the same, but the two lines are exactly the same line. That kind of situation is called a dependent system of equations. Because in this system of equations, the two lines are not totally independent. They really are just one line. They're both the same equation. It's a dependent system of equation. And any point that's on one line will be on the other line. So any solution of one equation is a solution for the second equation. In other words, there's an infinite number of solutions, any point on either of the lines. They're go on and on. It's not just one solution. It's not no solutions. It's an infinite number of solutions. Any point on the line is a solution for both equations. That is really very often, that does not happen very often at all, but it is a situation. So when we're talking about a system of equations, we have to decide, is it a consistent, an inconsistent, or a dependent system of equations? So let's see this system of equations that I gave you here, this particular one. Let's see if we could solve the system of equations when, again, find the point where they meet, or decide that there's no solution or there are infinite solutions. We are going to do this graphically now. On Tuesday, when we continue this subject, we're going to learn how to do that algebraically. We'll see that solving a system of equations graphically takes a lot of time and effort. And on top of that, you have to really do it on a piece of graph paper. Now, I don't have graph paper, so I hope I'll come out with the right answer. But if I didn't draw it exactly right, it's going to be very hard to read the answer. Okay, let's go to the first equation, which is x plus y equals 5. Now, we could either put this in the y equals mx plus b form and then use a slope in the y-intercept to graph it, or since this is already in what we call standard form, we could use, remember the other method that we use for graphing a line, we use the intercept method. Let's do that. So let's do one using the intercept method and one using the slope-intercept method. If we want to use the intercept method, what we have to do is to find the x-intercept, we have to let y equal 0. Remember this? And if I put y equal to 0, I'll just get x equal to 5, because it will be 5x plus 0, which is x equals 5. So my x-intercept is 5, 0. Let's put that on our graph. Here's my graph paper. Not very good graph paper. Okay, 5, 0 would be 1, 2, 3, 4, 5 to the right here on the x-axis. To find the y-intercept, we have to let x equal to 0. Now, if I let x equal to 0, I'll get the 0 plus y, which is just y, and we'll get y equal to 5. In other words, 0, 5 is my y-intercept. That means 1, 2, 3, 4, 5. Here is my y-intercept. And it would be nice if I had a ruler, but here is my line joining these 2 points. This is line number 1. The line that has both the x and the y-intercepts being 5. Okay, let's do line number 2. Now, line number 2 is y equals 2x minus 1. It's set up in the slope-intercept form. So I know that my slope is 2, which we're going to write as 2 over 1 because we're going to use it to draw the line, so we need it as a fraction. Rise over run. And my b, my y-intercept, is the -1. So if I want to draw the line using the slope-intercept form, I first go to -1 on the y. And from there, I'm going to go up 2 over 1. So I'm going to go 1, 2 over 1, 1, 2 over 1, and it should be a little bit over like this. And here's line number 2. And if you notice, these 2 lines do meet. This is a consistent system of equations. The 2 lines are meeting at this point, and this point is the solution of the system of equations. I have to read what this point is in order to find out what the system of equations, the solution is. Well, if I go to this point, I first have to go 2 to the right, so my x value is 2. And from 2 to the right, I then go up 1, 2, 3. The y is 3. That's why it would be better if this would have been on graph paper. It would have been much easier to read the solution. The solution to the system of equation is 2 comma 3. We could write it this way, or we could write it x equals 2, y equals 3. And you will see that it is indeed a solution because it works in both equations. 2 plus 3 gives us 5, so that works. And 2 times 2 is 4, minus 1 is 3, so 3 equals 2 times 2 minus 1. It works in the second equation. That's what it means it's a solution. It works in both equations. So here is my solution to my system of equations. This was a consistent system of equations, and the solution was the point 2, 3. Does anybody have any questions they'd like to ask me about this? I see there are some things on the chat. Let me see what the chat is. Can you do another one? Sure, I'd like to do another one. Can I erase this and do another one? Okay, let's try another one. try to making this up out of on the top of my head, so I'm hoping this is going to work. No. This one. Okay, let's do this. Let's solve this one. Let's do that by, again, the intercept method. I'm giving you a minute to try that out on your own. Okay, I'm going to try and do that. Okay, I want you to try an example number 1. Find the intercepts. Give you a couple minutes to do that. Okay, let's see if we have found the intercepts. We're doing the intercepts for number 1. Number 1, to find the x-intercept, we have to put the y equal to 0. So if I put the y equal to 0, I'll get x minus 2 times 0 equals 2. And of course, this will cancel out, so that'll just leave me x minus 0, which is just x, equals 2. So my x-intercept is the 2, 0. Here it is on my graph. One, 2, 0, right here. This is my x-intercept. Let's find the y-intercept by letting x equals 0. Okay. Putting x equal to 0 gets 0 minus 2y equals 2, which is just negative 2y equals 2. And if I divide by negative 2, I get y equals, positive 2 divided by negative 2 is negative 1. The y-intercept of the number 1 is negative 1, right here. This is line number 1. Any question about that? You okay with that? Okay. Let's go to line number 2 and see if we can graph line number 2. I have to erase this because I just don't have room for it. Here's line number 2. In line number 2, it's already in the y equals mx plus b form. So instead of using the intercept method, let's just use the slope intercept method. The slope is the number in front of the x, which is 2, which I write as 2 over 1 because I need the x and the y. The b, the y-intercept, is the negative 7. So if I want to graph that line, I have to start at -7 on the y-axis. So here's 1, 2, 3, 4, 5, 6, 7. Here's my y-intercept. And from there, I have to use my slope 2/1, which means rise 2, run 1. So here, I'm going to rise 2, go over 1. I'm going to do it another time. Rise 2, run 1. I could keep doing this. Rise 2, run 1. Something like this. Here it is. This is not coming out very good. Looks more like this. Here's where those two lines meet. Now here's where I run into problems as to, because I don't have this on a piece of graph paper, it's very hard to see what this point is. But if I look at this point over here, it looks like I'm going 1, 2, 3, 4 to the right. And it looks like I'm going up 1. 1, 2, 3, 4 to the right, up 1, which is a 0.41. I hope that 41 is the correct answer to this system of equations. I can check it by putting in these numbers into the equation. Here, if I replace x with 4, I'll get 4 minus 2 times 1, which is equal to 4 minus 2, which is 2, which is what it's saying, so it checks on that one. And here, 1 equals 2 times 4 minus 7, which is 8 minus 1, minus 7, which gives me 1. So it checks here as well. 4, 1 is the solution because it works in both equations. Again, this would have been much better. Those of you who want to try these, try it using a piece of graph paper. If you do it carefully on a piece of graph paper with using what we call a straight edge, a ruler, you will see that you'll be able to tell the point where they meet much better than what I've done here, which is sort of when you're doing it freehand. And that tells you what the problem with this is. When you're doing these things freehand, or when you're not, that you could be slightly off and your answer is going to be wrong. That's why we're going to next time do it by a different method altogether, which won't depend on us drawing anything. Does anybody have any questions before I close? Okay, I hope you have a good weekend. Don't forget to work out, do the homework that's been assigned on Delta Math. And don't forget that you have to be prepared for the test that's coming up on Tuesday. Again, it will be posted Tuesday after class. Have a nice weekend, everybody. I'm ending.
Bye, Professor.
Bye-bye. I'm going to close the session for everybody.